Alright, this is the next video for Year 13 Maths. We're looking at, excuse me, we're looking at exercise 11A. So it's a reminder about basic integration and also using the standard results that we're given in the formula booklet. Now we already know, so let's integration using standard results. So we already know that the derivative of sine is cos x, and so cos x integrates to sine x. Don't forget about your plus c. Likewise, the derivative of cos x is minus sine x, so sine x integrates to minus cos x. What else do we know? We already know the standard integration rule from year 1. Increase the power, divide by the new power. What else do we know? We know that e to the x differentiates to e to the x, so of course e to the x integrates to e to the x. We know that log x differentiates to 1 over x, so that means that the integral of 1 over x is log x. Now, people are often tempted when they see x and a minus 1, increase the power to 0 and divide by 0, but of course that doesn't work. We're told in the differentiation section of the formula booklet, we're given tan x differentiates to sec squared x, which means we can use the inverse, the integration of sec squared x is tan x. So although this is given in the differentiation section of the formula booklet, we can also use the results for the integration. What else are we told? We're told that cosec differentiates to minus cosec cot, and so we can say that cosec cot integrates to minus cosec. We're also given cot differentiates to minus cosec squared, and so cosec squared integrates to minus cot. And the last one, we're given that sec x differentiates to sec x tan x, and so of course sec x tan x integrates to sec x. So I don't need to write these down, I don't need really to remember them, just need to know that they exist. We're not given cos sine, we're not given e and log, but we are given tan, cosec, cot and sec. And so because we're given the derivatives, if you like, they've also given us the integrals. Now the integration section of the formula booklet does have some other standard results in, but I tend to find myself using the differentiation section to integrate more than I use the integration section. So let's work through the exercises just using standard results here. The integral of 2 cos x plus 3 over x minus root x. So reminder, root x I'll write as x to the half. Sine differentiates to cos, so cos integrates to sine, so 2 sine x. There's no chain rule here because there's just a 1 there. 1 over x integrates to log x, so 3 ln x, and then increase the power, divide by the new power, so minus x to the 3 over 2 over 3 over 2. Remember, I don't need the plus c till I give my simplified answer. Now occasionally you'll see a modulus around the x. That's just recognising the fact that you can't take the log of a negative. So sometimes you see log x written like that with brackets, or indeed with nothing. Sometimes you see it with a modulus. There's no difference. It's just acknowledging the fact that you can only take the log of a positive number. And I will put my plus c there because it's my final answer. Part B, the integral of cos x over sine squared x minus 2e to the x. So I'm going to write cos x over sine squared x as cos x over sine x times 1 over sine x, and of course that's cot x cosec x, and because I know that's one of my standard results, cot x cosec, there it is, cot x cosec integrates to minus cosec x. So I want the integral of cot x cosec x minus 2e to the x, all with respect to x. So cot x cosec, I look it up, I see that the integral is minus cosec x. 2e to the x integrates to 2e to the x. Don't forget plus c, because you will lose a mark without it. So again, standard results. Yes, we need to remember that that is one of my standard results, but that's what practice is for, isn't it? And let's do example 2. This is a definite integration because it has limits a and 3a. So there's the question. Find a. Remember, the process is you integrate in square brackets. Well, let's simplify first. So the integral of, I'm going to split this into two fractions. 2x over x plus 1 over x, that's standard. Now 2x over x, that's just 2. So integrates to 2x. 1 over x integrates to ln x. So remember, the process is you integrate in square brackets, leave your limits in, and then you substitute in your upper limit, substitute in your lower limit, and subtract one from the other. So 2 times 3a plus ln of 3a. Take away 2 times a plus log a. 6a minus 2a is 4a. Log 3a minus log a. Remember, log 3a minus log a can be written as log of 3a over a. 12. So 4a plus, well, 3a over a is 3, so log 3. So 4a is log 12 minus log 3, which is log of 12 over 3. So 4a is log 4, so a is a quarter log 4, or if you prefer, log 4 over 4. Of course, they're the same thing. So this exercise is just about using the standard results that you're given. There are a few examples where you have to rewrite the expression to get a standard result. That was this one here, and once you recognize it's a standard result, it's just looking it up in the formula booklet. So straightforward, I think. Have a go at 11A. I'll see you next time.